Okay, what you see here is an empty browser window, and what I'm going to do now is calling the online version of our paper. I type in its internet address, press enter, and there it is. So this is essentially exactly the same paper that is published in the icis proceedings. It's also formatted very similar, but there are some visual components embedded into it that we're going to have a look at now. So the first thing a reader would do would be start reading the text. And there's lots and lots of text, just as with any ordinary PDF. And he would read, and eventually he would end up seeing the first visual component in this case here. So, as you know, we're talking about business process mining here. And the first thing a reader would have to do is understanding what business process mining is all about. And as the name suggests, it's about mining some sort of information about business processes from data that is being observed. So this illustration here, this animation, is meant to facilitate the understanding of the user with respect to how this data comes into being. And we have shown a very simple PetriNet here that has 4 transitions called A, B, C, and D. And they are supposed to represent events that can be observed within this process. And we are interested in process mining into the structure of the process that is generating these events. And for this exemplary PetriNet, we see that there is first always going to be event A. And afterwards, we're going to see both events B and C. But there is no particular order, so they could be observed in any order. And then finally, we're going to observe event D, and that terminates the process. And in the animation, you now see that this PetriNet is continuously executed and afterwards restarted. So now we see A, now we see C, then we see event B, and then we see event D. And down here, these events are logged inside this event log. And this is the data we will later on use to recover the PetriNets that are generating the data. So after having understood the problem, the reader would now go on reading. He would see also a static picture and some formulas. He would read a lot of stuff about the algorithm that we are putting forth in order to do this. And then he would end up here, and he would first see a video. So this video is just a tutorial video that is meant to explain how the applet works that we provide in our paper. And this is also the main thing that I want to talk about now. So in this applet, let's suppose the reader has already seen the video and knows how the applet works. So in this applet, the reader can try out the algorithm. It's running on a server of ours, and this applet here provides an easy to use interface to experiment a little bit with the algorithm. And the first thing the user has to do to experiment with it is to choose a PetriNet that is generating the data. So in this case, there are several PetriNets here that he can choose. For instance, he could say, I want to use the PetriNet called Parallel. And then down here you can see which PetriNet it is, or how the PetriNet looks like. And as you can see, it's exactly the same one that we have seen up there in the animation. So first there's A, then there's going to be event B and C, but in any order. Finally, there's going to be event D. He could also use another PetriNet, for instance, the one called XOR. And in this case, he will first, the data will be generated according to the rule that there's first event A, and then there is either event B or C, but not both. And then there's going to be event D. Yeah, that's how the data is generated in this case. So let's say the user decides to choose process XOR. Then in the second step, he could modify the PetriNet. So he could minor modifications to this thing, but let's skip that for now. And then in the final step, he could say, okay, I want to execute the algorithm. Then there are several parameters or settings he could change. For instance, he could say, okay, I don't want to use the default 100 cases, but maybe only 50 or so. So cases, like the number of cases, determines basically how huge the data set is going to be. And there are also other settings that I don't want to go into detail right now. And finally, the user could say, okay, start the algorithm. And that would send a request to the server to start the algorithm. And the server already responded and sent us the picture, like the Petri net that the algorithm generates from the randomly generated data. So as we hit the start button, this process over here is randomly generating 100 cases. So it's executed 100 times. And then the algorithm that we have put forth in this paper is executed on this data and provides this result. And the user of this applet would then see, okay, well, the algorithm worked. So for this example, apparently it's a good one. And then he could say, okay, let's move over to the second example that is provided in this paper, the parallel process. And let's see how well it works now. Again, we don't modify it, and we also don't modify the default settings, the default parameters, but just start the algorithm and see what is outputted. And again, we see no problem for the algorithm. So also this model parallel, this process, can easily be recovered using the algorithm. And that's fine and so, but now the reader could say, okay, I want to come up with my own example. So I could say, well, in the problems I typically have to solve, processes look a little bit different. There's many more parallel activities in there. So for instance, he could say, this now is the process I want to mine. This now is the process by which data is generated in my case. And I want to do an experiment with it. I want to see if this algorithm works. So what he would now do is he would say, okay, I use a custom Petri net. He would click here. And then he would have to type in the textual representation. So basically before here, we had a textual representation for each of these Petri nets, which just consists out of a list of places, a list of transitions, and also a list of arcs, which are these arrows here in between the places and transitions. And after a couple of minutes, the user would come up with this text over here, which represents now the business process he is interested in. And after we will be hitting the start button soon, the data will be generated according to his Petri net and not to the ones we predefined. So let's again say the user doesn't want to change any of the standard settings and just wants to see how well the algorithm performs on his customly provided Petri net. So we hit the start button and we wait a little. Now the server is processing the request and sends us back the result. And unfortunately, we now see that the result doesn't really look like the process that we used to generate the data. So what the user was able to do now is to use his own Petri net that he defined himself and to uncover a weakness of the algorithm. He could now go on experimenting further. For instance, he could try to use a different number of states, because maybe that's the reason because this result is so bad. Maybe he could change the parameters a little, and he could do many more experiments to see if he can make the algorithm work or if this actually is a weakness. And this way he would get a little bit involved into the subject matter.